A tightrope walker is moving along a tightrope. I'll go ahead and draw the tightrope here. And the person is walking at an altitude of 100 feet. So we've got the ground down here. And this distance is 100 feet. The walker is tracked by a searchlight on the ground. So there could be a little light here. Okay. Find the change in the angle of elevation of the searchlight when the walker is 200 feet horizontally from the light. So we've got this distance here is 200, but of course it's changing. So I'm going to go ahead and just call it x. Okay. And that is when the walker is 200 feet horizontally. So if I drop this vertical here, and then this distance right here, we'll call that y. And then of course walking away from the light, walking this way. So we've drawn a picture and we've labeled it. I'll go ahead and draw the 100 right there. And then we're going to write down all the things that we know. Okay. Well, the speed or velocity at which the tightrope walker is walking is 3 feet per second. And that is the rate at which this distance y is changing. So we know that dy dt is equal to 3. The altitude never changes, so I don't need to write anything there. The walker is tracked by a searchlight on the ground, and then we're talking about the change in the angle of elevation. So there's this angle here, we'll call that theta. And we are looking for d theta dt, the change in that angle. So that's what we're looking for. When the walker is 200 feet horizontally, so that's when y is equal to 200 from the light and walking away from the light. Okay, so it looks like x doesn't even matter right now, so that's nice. But we've got this variable y and theta, and we need to relate those two variables. So to do that, we're going to use a trig function. I'm going to use the tangent function because we know the side opposite the theta, and we're trying to relate it to the side adjacent. So opposite and adjacent, I'll use the tangent function for that. So tangent of theta is equal to opposite, 100, over adjacent, y. All right, and then we can take the derivative. So first I'm going to write this as tangent theta equals 100 y to the negative 1. Okay, and then we'll differentiate both sides. So differentiating with respect to t, the derivative of tangent theta is secant squared theta times the derivative of theta, which is d theta dt. And then the 100 y to the negative 1, we bring the negative 1 down, so we get negative 100 y to the negative 2 times the derivative of y, which is dy dt. Okay, and then we can plug in all the things that we know. Now, we don't quite know secant of theta yet, but we can find it because secant of an angle, that's 1 over the cosine of the angle, or hypotenuse over adjacent. Okay, well, we know that at this moment the adjacent is y, and we know that that's 200. But the hypotenuse is this x. So we'll need to find that, and we can do that by using the Pythagorean theorem. So y squared plus 100 squared is equal to x squared. We know y, so we'll plug that in. So 200 squared plus 100 squared equals x squared. Well, that's 200 squared is 40,000. 40,000 plus 100 squared is 10,000. It's equal to x squared. So this is 50,000, so x squared is the square root of 50,000. So x equals the square root of 50,000. Which we can leave like that, or I'm actually going to simplify it because the square root of 10,000 is 100. So this is 100 root 5. All right, so now that we have that, we can get the secant of theta. Secant of theta is hypotenuse over adjacent, so that's x over y, or 100 root 5 over y, which was 200. Okay, so secant of theta is just root 5 over 2. Okay, it's like 100 cancel. So root 5 over 2. And that's secant theta, and then we square that. So root 5 over 2 squared times d theta dt, which is what we're looking for, equals negative 100, and then y is 200 to the negative 2, dy dt, which we know is 3. All right, and then we can simplify a little bit here. If we square this root 5 over 2, we get 5/4 d theta dt equals, we can go and simplify a little bit here. This negative power drops that to the denominator, so this is over a 200 squared. Okay, and then negative 100 times 3 is negative 300. We can simplify a little bit here by canceling out a 100. So we have negative 3 over 200 times 2, because we cancel out one of the hundreds. And then I've got this 5/4 d theta dt. Let's just multiply both sides by 4/5. 4/5. All right, and then that, of course, cancels those. We get d theta dt equals, well, the 4 over 2 cancels. There's a 2 up there. And that's all the simplification that can happen. So negative 3 times 2 is negative 6. Oh, sorry, just kidding. There's definitely more simplification that can happen. 2 over 200 simplifies down to a 100 in the denominator. So we get negative 3 over 500. Negative 3 over 500. And the units on this are the units on theta, which is radians, per t, which is measured in seconds in this problem. So radians per second. And just as a quick check on our work, we want to make sure that this kind of makes sense. First of all, we have a negative, okay? And so as this person is walking, that's saying that this angle is getting smaller, which of course makes sense, okay? Because it's going to be pointing, further down the line, and that gets smaller. And then 3/500ths, it's a pretty small number. That makes sense because it's, this person's walking 3 feet per second. The angle's not going to be changing very quickly at that moment.